Good morning. So today we're going to discuss, we're going to continue our discussion on time series analysis using ARIMA. And in the notes that I gave you, I wrote there Apple. Let's choose another stock, a stock that has been in the headlines for the past months because of a I don't know, I could call it a strategic blunder that they made. May I have a show of hands, please? How many among you are familiar with the story of Bud Light? As business students, it's important for us to know what happened here. Could you please chat, please? Just a yes or no? It's okay if you don't know, class. I just want to have a feel. Yes, no, no, no. Okay, no, no, no. Okay, no. Okay, good. Thank you so much for your feedback. How about the others? How about the others? Kulang pa yata to. Bud Light. Yes, yes, Michael. Bud Light. Yeah. The ticker symbol is Bud. Okay. So just a few of you, just a handful of you are familiar, and maybe because I discussed this also in FINSAR last term, albeit not really that extensively. But it's an interesting story about corporate failure, about a marketing gimmick that failed and failed really marketing campaign siya. No? Talagang nag-fail talaga yung strategy ng company. But let's first, we'll go back to that in a while. So I have here some references. They're not here, class, just for you to look at the they're here for you to look at the reference. No? So I will not discuss this anymore, but I will assume that you look at them, and so that in the first exams will be face to face. It will be about time series. I will assume that you looked at these references so that you're able to answer questions about time series. Okay, these are the packages that we're going to use. Allow me to give you some minutes to load these packages. I'm not putting installed packages here because I already installed this. But in your case, if you haven't installed it, kindly, you may try to see if you load library forecast, and if it doesn't load, it means that you haven't loaded it. So install that packages. Okay, let me pause. If you encounter difficulties in loading packages or installing packages, it will be very useful for you to Google the issue. For example, if you can't install FINLYTS, you can Google it, and most probably there's a reason why. Maybe it's not yet housed in CRAN. Okay, so it's still with the author. So you may be able to get this from the GitHub of the author. Okay, if you take a look at this, there are some messages that you'll be receiving. Okay, for example, here, package forecast was built under our version. Okay, hindi ko pa na-update yata yung ARCO. No? Okay, and then attaching packages. So, si forecast, sabi, it warning, sorry, this is, wait, saan to attaching packages? Why is this? Dapat kay, ano to kay Tidyverse. Okay. Para nag-load din si Tidyverse dito. Okay, so apparently when you loaded a particular package, usually this happens with Tidyverse. I don't know why we're getting this message. So is it coming from forecast package? Kasi class, pag try natin why don't you do this? I-library nyo nga class, library. tidyverse. Tidyverse is a family of packages also. Okay. If it doesn't load class, it means that you have to install it first. And then you'll get this message. Kindly chat if you got this message once you have installed tidyverse. Okay, thank you, Franz. How about the others, please? Okay, thank you. All right. So thank you so much, class. Tidyverse is a family of packages. So it says here that, okay, thank you. It says here that, okay. All right, so let me continue. Warning, package tidyverse was built under our version. So it attaches the other packages, forecasts per read R, string R. Okay. Hindi niya sinabi pa, maraming kasama pa yan, si dplyr, si ggplot2, ayan, dplyr. Okay? Now, there's also a message here. Sabi dito, yung plotly na package which comes for also installed or loaded with tidyverse, may function siya na filter. And then it masks another function called filter, same function filter that comes from time series. So since this function filter are used in both packages and both packages are loaded now, okay, there will be a conflict. So this means that if you just use the function filter, it will use the filter from the plotly package. Now, if you want to use the filter from the time series package, you'll have to use this time series, then colon, colon, filter. Okay, otherwise, if you just use filter, ito lang gagamitin natin, and then you put your code here inside, then it will assume that you're using the plotly package. That's what this means. No? So you have two packages with the same function, filter, okay? And this tells us that the filter function from plotly masks the filter from time series. So if you're intending to use the filter from time series, then you will have to use the namesake time series. Okay, kasi naka-default kay plotly. Okay? Yan, then so merong iba, no? Okay. So let's continue. We discussed this last time in CTSM. I hope you have loaded it. Okay, so last time we started discussing what an ARIMA function is, what an ARIMA model is. We said that the ARIMA model was developed by Box and Jenkins, and it's used for time series modeling. Time series modeling, okay. All right. Annotate natin. Okay. So Box Jenkins approach to, no? And we discussed what an ARIMA model is. It's broken down into the AR process, the MA process, and the integrated process. Okay, that's ARIMA, autoregressive integrated moving average. And last time, what we did was to take a look at, let me clear this first. Okay, we defined what an AR1 process is, diba? Sabi natin that an AR1 process consists of your model is expressed, your time series is expressed as a certain constant, delta, plus your lag1 value times a certain coefficient, phi1, and then an error term. So this is an AR1 process, an autoregressive process, and it's called autoregressive because you're modeling your time series based on its values of itself, albeit lag value. Okay, so we said that the error term last time, the error term should be, okay, the epsilon sub t should be, it should be normally distributed with zero mean and constant variance. Okay, yung error term natin. Diba? I showed you last time the residuals, the plot of the residuals, and it's important that the residuals should be, wait, did I show you? No, I'm sorry, it's not in this class. No? It's in another class. So, but the error term here, the epsilon sub t, okay, it's independently and identically distributed with zero mean, okay, zero mean and constant variance, sigma squared. This should be constant. Independently distributed with a normal distribution, itong n siya, zero mean and constant variance. So that's what that okay. All right. So if it's an AR2, we also describe this class. An AR2 process includes this. So we have the AR1 and the AR2. This is the coefficient for AR1 and coefficient for AR2. This is also, again, the constant plus a certain error term. So this is how a time series can be modeled by using its past values. Okay. Clear again? Okay. In general, an ARP process, we said last time, okay. So ARP, the P here stands for the lag of the autoregressive process. So P lags indicate that there will be there will be P lags of predictors. So this is x sub t minus 1, this is lag 1, x sub t minus 2, etc. until x sub t minus p. So this is just to generalize the lag P lags of predictors. Okay, so same thing. You have your intercept, you have your constant, you have your predictors, you have your lag 1, lag 2, lag 3, etc. Lag of p minus 1 and lag of p plus a certain error term. Okay, so we said last time that you can write these equations neatly using the LaTeX method of writing equations in R. Okay, how about the MA process? We said that the MA process, we use the log of the error terms. So you can see here that the model for our time series is equal to, again, another constant. Okay, this time we're using mu for the MA process plus the error term plus the error term log 1. Okay, and then we have this coefficient theta 1. Okay, same thing with the MA2. You have two lags of error terms. Okay, so your time series is modeled using the error of the current error plus the error of the one lag and the error of the second lag. And then if you have an MAQ process, so for AR, it's P. Okay, For MA, the symbol used is Q. So if you combine, for example, AR and MA, you write ARMA PQ. Let me write it here. ARMA, oops, not inside. Oh, what happened? Okay. Na-delete ko. Just write it here. Ito pala, no? Sinulat ko pala. Ito class, no? An ARMA PQ process. You have the P indicates here the log of your AR, and the Q indicates the log of your MA process. Okay, any questions so far? Let me pause for a while, and just in case you have questions, I'll entertain them. Okay, let me rephrase it. Clear so far, class? Paki-chat naman kung yes or no. Clear so far. Review na lang to actually, no? So far, yung discuss natin ngayon. Thank you. Okay, waiting for the others' response. Okay, good. I hope to get 100% response from you, class. Okay. All right, so below is an equation for an ARMA PQ. Okay, so how do we write an ARMA PQ? Sorry, this is an ARMA 11, no? ARMA 11. So ARMA 11, you have log 1 of your AR process and log 1 of your MA process. So we have a certain constant C plus your phi1, the coefficient of your log 1 of AR, plus your error term, plus theta 1 times the log 1 of your error term. Okay, so it's quite easy to generate the equation, or to write the equation. If you know the phi and the theta, okay, that will be very, very easy to just write a general equation. And if you know C, the general equation for your time series using ARMA. Okay, for ARMA 21, okay, so everything here has been given to you. You have, so pag 21 class, ARMA 21, log 2 ng, we have 2 logs for the AR process. So that's why we have here phi1 and phi2. And then 1 log for your error term. So this should be, sorry, this should be theta, should be theta 1. Kindly correct na lang. Theta underscore 1. Wait, parang may mali ako dito. Theta underscore 1, tapos, lagyan natin ng space, epsilon. Oops, naka-capital. Epsilon n, oops, underscore epsilon. Mali ito. Epsilon. I have here epsilon. Why?
Sir? Sir?
Yes?
I think 2 underscores po yung nailagay nyo.
Wait, ito no? Sorry. Humaba yung underscore dito. Ayun, okay. Sorry about that. No? Okay, but since I'm using E here, no? So medyo mali din ako dito kasi nag-epsilon ako dito, pero dito E, no? So dapat consistent yan. So let me just use E to be consistent. And that refers to your error term. E, there, no? Underscore, this is if you're subscripting. If you want this to be superscript, caret, no? Tingnan nyo. Pag caret, naka-superscript siya. And then if it's an expression, naka parenthesis, naka curly brackets. Okay, so let me redo that. Underscore. Oops. Yan. Theta 1 times epsilon t minus 1. If you want to put a space there, kasi kahit ano ka dyan, space bar, hindi ano yan eh. Either you can use the curly brackets there, the curl here, in order to give space here. Lagyan ko lang ng tilde, no? Para magkaroon ng space dito. Okay, anyway, I'll just remove that. Okay, ang importante dito class yung ARMA 2-1 process, no? You have 2 lags for your AR process, okay? And then 1 lag for your MA process. Okay, once you get the hang of it, once you get the pattern, this is very easy already. Okay, any questions so far? Okay, and then let me rephrase it. Is everything clear so far, class? Is everything clear so far? Okay, good. Thank you. Okay. All right. So let's continue. Okay. So, ito class, anong process to? Can you tell me what process is this? What model is this, class? Kindly chat, please. Is this an ARMA? Dapat pag nakita natin yung equation, alam na natin kung anong ARMA process yan. Kindly chat, please. What process is that? What ARMA process is that? This one. C plus phi2 x sub t minus 2 epsilon sub t plus ARMA 2-1. Okay. ARMA 2-1. Okay, let me ask Luis. Ay, hindi, sorry. So, yes pala yun. Asan yung who was the one who answered first? Rhea? Ay, hindi, sorry ah. Hindi ko makita. Sino yung unang nag-answer ng... Okay, Michael. Michael, bakit ARMA 2-1? Tsaka hindi pwedeng 2-1 ha. Kailangan isabi mo ARMA. No? Kasi may ARIMA din. No? Bakit Michael? Bakit 2-1?
Hey, sir, at first glance, akala ko 2-1 siya, pero I think mali ako.
Ano sa tingin mo?
Wait lang, sir.
Sige lang. Kasi ito phi sub 2x minus 2, x sub t minus 2, and then ito theta 1, epsilon e t minus 1. So
Wait,
your
joke lang, sir. Yeah, I think it's 2-1 po.
2-1. Oh, okay. Tama yung 2-1, no? Thank you, Michael. And so the rest also answered, thank you. You're correct. This is 2-1. Now, is it still 2-1 kahit na yung phi sub 1 natin hindi wala dito? Yes, it's still ARMA 2-1. Kasi ang tinitingnan natin dito yung ano yung highest lag, yung highest order, no? Ito, t minus 2 for the AR process kasi phi sub 2 to. And then ito epsilon sub t minus 1, lag 1 ng error, no? Okay, this is still ARMA 2-1 even if you don't have x sub t minus 1. It only means that phi 1, yung coefficient ng x sub t minus 1 is equal to 0. Okay, so that's what this means. So we'll take a look at the highest lag. Okay, so ARMA PQ in general, P logs of how do you write that? So pareho din, ito yung ARMA P component, ARP component, phi sub P times X sub T minus P. And then dun sa MA component, you have your using theta, okay, theta sub Q. Dito ang ginamit, okay. Dapat ito class, no? Sorry. Ba't ba W na gamit ko? Theta 1. Okay. Sandali, Let me change. Control F. So dito, look for W, and replace it with E. Yan. So I'm replacing W with E, just to be consistent with what we have discussed. No? Replace, sunod ng W, replace ulit, replace. Okay. Okay na. So, we now have our model. Tama na siya. No? Uy, yung huli hindi ko napalitan. Where's that? Tama. E sub T minus Q. Okay? All right. So, I changed the W. Apologies. It should be epsilon E. No? E sub T minus 1, E sub T minus 2, until T minus Q minus 1. Okay? And then T minus Q. And then you have your different coefficients. This is phi sub P, and this is theta sub Q. So this is an ARMA process. Okay. So how about an ARIMA PDQ? Okay, the D here, class, means that the series has been differenced. And I think I discussed with you last time what does differencing mean. So you're actually creating a new time series. Okay, so it's not the original time series anymore. A difference time series is already a different series. Okay, so if you have your data 10, for example, your data is 10, 9, and then 9, 8, etc., which is your original time series, the difference time series will now be a difference of consecutive values. So you have 10 minus 9, that's 1, and then 9 minus 9, that's 0. Okay, I hope you get what I mean. So I'm now getting a series that's 1, 0, etc. So that's different from the 10, 9, 9 original series. So we're actually now modeling a different time series now. Okay, so the question is this useful? Because we're now modeling a different time series, right? What we're interested in is to model the original time series. Okay, but it's okay because you can easily revert back to the original one. After you create the model, you can revert back to the original one. Because what's the purpose of creating a model? One of the main purpose of creating a model is to predict, let's say, n steps ahead. For example, we'd like to predict either, let's say, 5 days ahead, 10 days ahead, or 12 months ahead, etc. So since that is the objective, how do we do that? We have to model first. We have to create a model, and then from that model, we'll be able to predict. Since we have already an equation, then we can predict, and after predicting, we can revert back to the original time series and convert the values of our prediction, which are difference values, to the original values. Okay, we'll have an example of that as we go along. All right, so in a nutshell, what are the steps so that we can generate an ARIMA model? So let's take a look at this very quickly. Number one, we have to plot the data and look at the data. We have to have a visual. If the data is not stationary, okay, what do I mean by stationary? Stationary means the data has no trend, it's constant in mean, and constant invariance. That's what we mean by stationary. Why is that important? It's important for the data to be stationary before we can use the ARIMA process. That's the requirement in order to generate an ARIMA process. That's why the D here comes in very handy. Because when do we use the differencing? We use differencing if the data is not stationary. Okay, if the data is not stationary, then we cannot use an ARIMA process for that. So what do? One transformation that can be done in order to convert the data from non-stationary to stationary is by differencing. So this is the role of differencing. Okay, so step one, check. Plot the data, check if it's stationary. Okay, what do we mean by stationary? Stationary in mean and stationary in variance. Okay, constant in mean, constant in variance. I'll show you examples of this. Let's just quickly go through the process. Okay, if it's not stationary, then you'll have to do transformation, data transformation. Now, if it's not constant mean, okay, it means it has a trend. It's going up or going down. An immediate remedy for this is to just get the difference. Differencing will address the trend. Okay, whether it's a positive trend or a negative trend, if you get the differencing, it will address the trend. Now, in rare instances, that the trend might not have been addressed, so you may take another differencing. Okay, so you have a double differencing now. And when you difference again, that means you're generating another different data, different from the first difference data. Okay, I hope you're getting that, class. No? Kasi you will repeat the process of differencing to the difference data. So dalawang differencing ka na. Okay, so it's different from the original data, and it's also different from the first difference data. So if the original data has 100 observations, the first difference data time series will have 99 observations, and the second difference data will have 98 observations. Okay, let me pause for a while. Okay, and all right. May I have, class, your comment or your feedback kung clear yung yung differencing at saka yung double differencing? I-summarize ko lang, ha. Why do we need differencing for? What do we need it for? We need to difference if the data is not stationary, especially if it has a trend. Okay, and the simplest way to transform your data so that the trend is removed is by differencing. Usually, sa first differencing pa lang, na-address na kagad yung trend. Okay? But sometimes there might be a need to have a second differencing, okay, to address the trend. And also, take note, there might be also a need for seasonal differencing. Ang differencing, class, hindi lang laging value at time t minus value at time t minus 1. It's not always like that. It can be value at time t minus value at time t minus 12, especially if there's seasonality. No? Kunyari, may monthly seasonality, ibig sabihin your values, let's say they show trending, they show seasonality, kunyari every December or in certain months, then ang differencing, mas maganda kung seasonal differencing din. Okay, we'll have an example of that. Medyo mahirap lang i-explain in words dito. Okay, so you have to do differencing. My question dito sa Glenn, is differencing and seasonalize the same thing? The same thing siya kung ang differencing mo is on a lag of, let's say, yung deseasonalize kasi dyan, and there are different ways to deseasonalize, pwedeng differencing din, no? Kasi meron ding multiplicative na deseasonal eh. So in that case, hindi same siya sa differencing. Yung difference kasi, di ba, nagma-minus tayo. when you decisionalize a data, kasi pwedeng i-divide, pwede ka mag-divide ng a certain factor. Okay, thank you Glenn for that question, ano, kasi yeah, medyo in a sense pareho siya kung in order for you to kasi merong additive decisionalizing, meron din multiplicative. Yung differencing is just the additive. Okay, kunyari may seasonality siya, ibig sabihin yung values every December tumataas. Maybe the company, it's a time series on, let's say, sales of let's say Christmas cards. Although hindi na uso ngayon yung mga ganyan. Let's say okay, sa Philippine setting, ano ba yung ayan, yung mga components ng buko salad yan, fruit salad. Alam nyo, kailan lang sa Pilipinas, grabe yung makikita nyo if you buy sa groceries, kailan grabing dami ng nagsa-stock yung mga groceries ng ng fruit salad, fruit cocktails, whipping cream, nata de coco, kaong, lahat yan kasi staple ng Filipino yan di ba? Filipino families. Okay, usually staple yung mga ganyang food or whatever, no? I'm just giving an example. So yung mga product na to, it can be that during the Christmas season, tumataas talaga sila, may mga spike sila ng sales. Okay? So since every December nagtataasan yan, so meron tayong seasonality component. Now, pag ganyan yung data natin, may trending yan, no? Tumataas tuwing December, tumataas. So may trending siya. So paano natin tatanggalin yung trending yan? Difference natin. Pero ang i-difference natin, hindi yung January versus February. Ang i-difference natin yung December versus December. Okay? Kunyari, December 2011, December 2012 minus December 2011. December 2013 minus December 2012. Okay, so that's what we call seasonal differencing. And yung decisionalized kasi naman, meron niyang multiplicative eh. So what you do, pag multiplicative, you divide the values every December ng a certain factor. Okay? So kunyari, meron din sa let's say sa November, meron din. November, kunyari flowers naman kasi yung we visit our loved ones who have parted. So marami bumibili ng mga flowers, dadala sa So usually pag November tumataas yung yung mga sales ng flowers, or February, ganun din. Okay? So Glenn, I hope I answered your question. Nasagot ba yung question? In a sense pareho siya. Kung nagdi-difference lang tayo Pero kasi may decisionalizing na na multiplicative. So you divide. Okay, you divide depending kung anong months, no? Yung November months or December months, etc. Na-answer ba yung question mo, Glenn? Okay. All right. Any other questions, class? Okay, so let's move on, class. So kailangan natin, inspect muna yung data. Kailangan i-plot natin para makita natin kung may trend yung data. If the data has a trend, then we have to detrend it. Okay? Depende kung ano yung trending. Okay, there are ways to remove the trend, and the easiest way, and usually isang difference lang okay na. So step 2 dito, difference data to make data stationary on mean. Ibig sabihin, remove the trend. Sometimes the data can also have non-constant variance. Pag ganun din, hindi din siya stationary, no? So in that case, if the data has non-constant variance, and how does that look like? I think I mentioned to you last time. Okay. So this is our data. Okay. Ito yung data natin, no? Series natin. So ito, hindi stationary yan, no? Bakit? May trend eh. So how do you address this trend? You difference. And usually, sabi natin, first differencing okay na. Okay? Unless yung data natin parang ganito. No? Ganito yung data natin. No? So, ibig sabihin, there are some particular periods na tumataas siya and some particular periods na bumababa siya. Okay? So, ito may trend siya, kaso may mga seasonal trending din. So, this might require not only a regular differencing but also a seasonal differencing. Okay? If the data behaves this way. Okay, tapos, pag yung data naman class, medyo non-constant yung variance, kunyari ganyan. Okay, sabihin natin ganito yung data natin. Alright, it might not have a trend. Okay, but ito, non-constant yung variance. Ibig sabihin, over time, the values are either, yung variance niya, lumalaki, no? Or pwedeng paliit. Pag ganyan, non-constant variance yan. Now, if it's non-constant variance, then differencing will not address it. Hindi matatanggal ng differencing yung non-constant variance. What transformation can be used? One transformation is the log transformation. Okay? So, ilog yung data para ma-address yung non-constancy invariance. If you log the data, class, ibig sabihin nun, you're generating another time series. No? Iba na yun sa original kasi nakalog na yung data natin. Okay, so what are you modeling? We will now model the log data. Okay, now why do we need to do that? We need to do that because we cannot do an ARIMA model class pag hindi hindi stationary. Okay? Hindi pwedeng i-model to use yung ARIMA kapag not stationary yung data natin. So what do we have to do in order to address it? I-log natin yan. Okay? All right, then step 4, difference. So ang sabi natin dito, di ba? All right. Ito, later on, i-discuss natin to kasi importante yung order. Okay, importante yung order. If we difference first the data and then log transform it, we might have a problem. No? Okay. Now, of course, class, kung ano lang siya, kung not stationary in mean lang siya, wag nyo na i-log. Okay? Just difference it. Why will you unless yung model nyo talaga kailangan i-log yung data, no? Okay, but if there's no issue about the constancy invariance, don't log it. Unless you really have to log because yun yung metric na talagang ginagamit. Kunyari, returns. Stock returns. So, ang stock returns ang usually ginagamit ng class, yung log returns. So, kailangan talaga i-log yun. Okay? Alright, then, sabi dito sa step 4, if kailangan pareho, no? Kailangan parehong kasi may presence na, kunyari, yung data natin, ano ba tong, okay, sandali let me just clear my drawing first. Okay, so suppose our data is like this. Okay, what can you say about the data? Generally, may trend yung data, no, pataas. Okay? Alright, so itong pataas na to, class, yung trend na to, that can be addressed by differencing. But also, di ba, merong non-constancy yung variance yung ano natin. Over time, class, lumalaki yung variance ng data set natin. So how do we address that? To address that, you get the log of the data. Now, ang question, if we need to do both, ano yung unang gagawin nyo? Do you need to get the log and then get the difference? Or do you need to get the difference and then the log? So which is which, class? Pakilagay nga option 1, log then difference. Option 2, difference and then log. Kindly chat please, write 1 or 2. Ano sa tingin nyo? Try nyo lang, class. 1. Ang 1 is, get the log first and get the difference. Okay, Adi, why 1?
Hello, sir.
Yes.
This is an attempt lang po, pero
Yeah, sure,
kasi
sure.
based on the description ng steps kasi, lalo na kasi yung itsura ng graph,
Mm-mm.
even though may upward trend siya, the data is scattered.
Mm-mm.
So, it would make sense then muna to muna to log the data, to make it stationary para hindi siya maging scattered, and then from there you remove the trend. From there you go with step 2 po.
Okay, pero
Parang
sinabi
ganun.
mo kanina, you get the log to make it stationary. Definitely
Apo.
by getting the log, it will not address the trend. So you don't make it stationary. Diba? Kasi you said that when you get the log, you make it stationary. You're not going to make it stationary by getting the log. You will not be able to remove the trend. But your answer is correct, no? Thank you,
Okay,
Adi,
sir.
for that.
Thank you, sir.
Tama yung answer mo na dapat gagawin yung log. But the reason is, class, if we get the difference, no? Sabihin natin, kunin mo natin ng difference, tapos kinuha natin log. Okay, what will happen? If you get the difference, you'll get negative values. Okay? And getting the log of negative values is not existent. Error yun because sa range ng ano, you cannot get the log of negative values. Okay, so that's a very important class, no? Subukan natin class, ha? Okay, tingnan natin. Iran lang natin dito sa ano. Okay, let me clear this. Okay, why don't we get the log of, close muna to. I'll cross filter. Why don't you get the log of -3, for example? Sige nga, class. What do you get? Answer, please. What do you get if you get the log of -3? Hello, class? Hello? Imaginary number? Okay. Ito nakuha mo, Adi. May plus ano? Surprise ako sa Adi sa na-generate na ano. Can you share your screen, please, Adi? I just want to know. Stop share ako.
Hindi, sir, calculator lang po yun.
Calculator. Sa
Sorry,
R na lang.
hindi sir sa, pala po.
Oh,
Apo.
ba't kayo nag-calculator?
Hindi, pero sa R po, ano yun, NaN po.
Okay lang
NaN
nga.
po din
Oo.
sa akin,
So,
like the others.
Ang log ba ng negative number is imaginary? Wait. I don't think so. Okay. So class, hindi kasi pwedeng kunin yung log ng negative number. Why? Kasi assuming na base 10 to, Okay, assuming na base 10, lagyan natin dito. Base is equal to, sabihin natin log of -25 para perfect yung positive niya. Base is equal to 10. Hindi, gawin natin -100 para perfect. Okay. Bakit, class? Ano ba ibig sabihin ng log of -100? Ibig sabihin ng class, what number, okay, if you raise 10 with, will give you negative number. Will give you -100. Parang 10 raised to what number is equal to -100? Diba? So 10 raised to the, hindi naman squared, no? 10 raised to the 2 is 100. So there's no number such that when you raise 10, when you raise that number by 10, okay, when you raise 10 to that number, okay, you'll generate 100, negative 100. So that's non-existent. Kaya not a number yan siya, no? So that's why you cannot first get the difference and then get the log because you'll get errors, no? Hindi natin kasi pwedeng kukunin yung yung log ng negative. So to address that, what we do first is to get the log and then get the difference. Kaya nga sabi ko dito sa step number 4, sinabi ko ba dito? Difference log transformation to make data. So you order dito, no? First get the log and then get the difference to make the data both stationary on mean and invariance if necessary. Okay. Then once we have done that class, if we plot again, we will see that the data is already stationary, no? Pag plinot natin data. But we can also check it statistically. So there are statistical tests to check if your data, your transformed data that is already stationary. Kunyari, nag-log tayo, tapos kinuha natin differencing, no? So our data is, let's say our data is X. Okay? X. Tapos, what we're going to do is get the log of X, let's call it LX, and then get the difference. So this is the object now, DLX. Our object is now the log of the difference of X. Of course, you can name it any other way, no? So, but this for me represents the data set that was originally X, and then we transformed it by getting the log, and then we made another transformation by getting the difference. So this data is totally different from the original data. Okay, but later on, since we're interested in forecasting our data, once we have our model, we can revert back to the original data. Kasi syempre, ang gusto nating i-predict, kunyari sales yan. Hindi naman natin i-predict, hindi naman natin gustong ang i-analyze natin yung predicted na difference log data, di ba? It doesn't mean anything for us. Are you getting me, class? Class, clear ba yon? I hope I'm clear. Am I, class? Hello? Mukhang hindi clear yata. Okay, let me repeat the explanation. Okay, thank you so much. But let me repeat the explanation. May original data tayo, X. No? Kunyari, itong data na to, kunyari, stock prices or sales ng isang company. Gusto natin mag-predict ng sales. We want to predict sales for the next, kunyari, if it's monthly data for the next 12 months. And one method is by, kasi time series siya, we can use ARIMA. No? Pag ARIMA, kailangan stationary yung data. Sabihin natin non-constant mean, non-constant variance. So we will have to transform the data. We first get the log of the data to make it to make the variance constant, and then we get the log, the difference to make the trend, to make it constant in mean. So ito stationary na to, no? So magge-generate tayong model based on the difference log ng X. Yung model na yun, class, okay, let's say ARIMA siya, let's say ARIMA 3, so if we're modeling this class, sabihin natin ARMA 3.2, no? ARMA 3.2. So that's three logs of your AR process, and the 2 logs of your MA process. So once we have generated that model, we can now create predictions. Pag predict natin, class, ang value na makukuha natin yung predicted values ng DLX, di ba? Hindi yan ang kailangan natin. Ang kailangan natin yung predicted values na X. So magre-revert lang tayo. I'll show that as we go along. No? Kung paano natin magagamit ngayon yung predicted value natin na DLX and convert it into X. Okay, class, klaro yon yung objective natin. Okay, good. Okay, kasi hindi naman tayo interested dun sa sa predicted values na DLX. Interested tayo sa predicted value ni X, di ba? If you're going to give a report to management, for example, to the executive officers, okay, ano yung predicted values natin for 2020 to 20, etc., no? Tapos magbibigay ka ng mga strange numbers na Sabi natin may mga 0.0 something pa, tapos et cetera. Sales mo, kunyari, 0.12 lang. Okay, so that will really look ridiculous, no? Why? Because what we forecasted is a different time series, difference log x. So what we have to do is to convert it to the original data. All right, say good. Now, ito na class yung ano. How do we test if the time series is already stationary? May mga statistical tests. First, you have the augmented Dickey-Fuller test, very popular test. And this one, Koyotsky, Perron, SS something, nakalimutan ko yung SS, no? These are names of the statisticians who developed this test. So you have the augmented Dickey-Fuller test and the KPSS test. Okay, malapit na mag-time. Tapusin ko lang tong steps class, no? Okay, then what do we do? After we have tested that it's already stationary, kailangan, itong mga steps na to class, very important. Yeah, thank you. Yeah, thank you, Michael. Kwiatkowski, Phillips, Mid. Yan. Yung sinare ni Michael. Copy nyo lang class para alam nyo, no? Copy nyo yan kung ano ibig sabihin ng KPSS test niya, no? Yan. Kwiatkowski, I haven't checked the pronunciation. Phillips, Mid, and Shin. These are the proponents of this test. Si ano naman, Dickey-Fuller test to. ADF, augmented Dickey-Fuller test. Okay. Yeah, thank you, Michael. Augmented Dickey-Fuller test yung ADF. Okay. So now we go to the concept of ACF and the PACF. Oh, okay, it's already time, no? So kindly read on this. Ano yung ACF at saka PACF? Ano yung autocorrelation at saka partial autocorrelation? Hindi tayo umabot pero I had wanted to to discuss with you how to compute the ACF and the PACF. It was more relevant, I should say. Conceptually, it's very important. But yung pag-compute ng ACF at saka PACF, dati manual kasi namin ginagawa, no? Kaya imagine how tedious it is. Just to create one model for a time series, it takes long. Ngayon class, ang dali-dali na i-generate yan with R. So, wala na sa ating problema to yung pag-generate ng ACF, PACF. And then once you generate step 6, we can now guess the ARIMA model. You will base the ARIMA model based on the ACF plot and the PACF plot. That was before, no? So medyo trial and error yan. Mag-generate ka ng ARIMA model based on the ACF and the PACF plot, but you will have to test that model. Nowadays, class, hindi na. R will do that for us already. Bibigyan na sa atin yung final model, the best model already. So it's really already parang a walk in the park na tong ARIMA. It really made the process very easy kasi hindi na in manual. Ganun ang advantage, class. That's your advantage kasi hindi kayo dadaan. Dati when I was doing this several years ago, when I was still studying this, tapos manual kami. Naku, isang model lang, isang araw na, no? Samantalang ito class, isang model lang, 5 minutes tapos ka, no? 5 minutes, so 60 divided by 5, 12 models. Hindi nga, less than 5 nga, actually 3 lang. 3 minutes tapos ka. So 20 models in 1 hour. Imagine. Grabe yung power ng mga tools yan like R. All right, so let me end in this class. Let me stop recording.